Welcome to EPIT slash Private Limited. Today we came with a new product. This is about wheelchair automation for physically handicapped people who are not able to control the vehicle through using their hands or legs. So this vehicle can control by using their head movements like right, left, forward, back and stop. And here we are using a electronic circuit board for this electrical motors driven wheelchair. Here you can see some drivers and STM32 board NRF for wireless communication. This is NRF module for wireless communication where it will receive the data from transmitter side of XYZ axis data. Based on that transmitter side, we will control this. We will give the signal to the drivers and the motors will drive forward, backward, right, left. And we will see the transmitter side circuitry, and then we will see the working of the device. So this is the power supply SMPS for the receiver side. We can replace this with the battery supply 12 volts, and for testing we are supplying it with the SMPS. This is the transmitter side circuitry, and here you can see on STM32 board and NRF module and a battery power supply. And here this is a cap equipped with ADXL335 sensor. There is a accelerometer which will give the directions of the head movements, and based on this data we will transmit this data to vehicle and vehicle moves accordingly. So we will test the vehicle by giving power supply.
Let's go to the working of it. Initially it will be like a messy connection because it's a prototype, so we then convert into a small chip and we'll put here everything. So I'm giving the power supply, so it is having an NRF module and even the receiver has an NRF module. So whenever I give the power supply, so NRF module will pair, and I am having an ADS accelerometer sensor. Depending upon my angular movement, it immediately reads and then sends using an NRF module. So directly go to the working. So I'm powering up, and even I need to power up the device, so I'm just powering up the device. So you can see depending upon my angular movement it turns. I go right, I go back, I go right, and I go straight, I go back. Depending upon my values, so depending upon our angular movement, it easily controls. So now we are installing a battery under down, and we are just making a small chip to connect over here. That's it, and it can lift up to kgs of 80, and the battery endurance will be about an hour. And the charging will be around 40 minutes. And let's go for the part 2 video after we convert into a fully battery operated. Thank you.